Okay, boys and girls, this is Mrs. Oestreich, and today we'll be working in our Go Math, Chapter 6, Lesson 1. Our essential question is, how can you use models to show equivalent fractions? Okay, let's begin. Oops. Okay, let's investigate. Joe cut a pan of brownies into third-sized pieces. He kept 1/3 and gave the rest away. Joe will not eat his part all at once. How can he cut his part into smaller, equal sized pieces? Okay, let's look at the model. Here is the model. Draw on the model to show how Joe could cut his part of the brownie into 2 equal pieces. This is the entire brownie. It's cut into thirds. This is Joe's part, and he wants to cut this part into 2 equal pieces. Okay, so let's do that. There are 1, 2, 3, 4, 5, 6, 7, 8 parts. 2. If you divide this by 2, you will get 4. So 2, 1, 2, 3, 4. So these are equal pieces, 4 on the top and 4 on the bottom. Okay, whatever you do in fractions to one piece, you have to do it to all of the pieces. Okay. You can rename these 2 equal pieces as a fraction of the original brownie. Suppose Joe had cut the original pan of brownies into equal pieces of this size. How many pieces would there be? So now there are 1, 2, 3, 4, 5, 6 pieces. What fraction of the pan is 1 piece? 1 piece is 1 out of 6. So that's the fraction 1/6. 1/6 of it is 1 piece. What fraction of the pan is 2 pieces? 1, 2. 2/6. So this piece here can be either written as 1/3, or if you break it in half, it would be 2/6. So you can rename 1/3 as 2/6, and it's equivalent. He ate 1/3 of the whole brownie, or 2/6 of the brownie when he broke it into halves. Let's go to the next page, the next problem. Okay, let's see what the next problem. Now draw on the model to show how Joe could cut his part of the brownie into 4 equal pieces. We still have a whole brownie. It's split into 3 pieces, one to him and one to each of his friends. But now he wants to cut his part into 4 equal pieces. So let's do that. So 1, 2, 1, 2, 1, 2. So as I said, whatever you do to the one piece, you have to do to all the pieces. So now he has his brownie in 1, 2, 3, 4 equal pieces. How many pieces will there be? Let's count them all. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There'll be 12 pieces now. Which fraction of the pan is 1 piece? 1 piece is equivalent to 1 out of 12. So one of these pieces is 1 out of 12. What fraction of the pan is 4 pieces? 1, 2, 3, 4 is 4 twelfths. So we can say 1/3 is equivalent to 4 twelfths. So therefore, 1/3 is equivalent to let's write this 4 twelfths. Oops, can't I write this? Is equivalent to 4 twelfths but from the previous page, it's also equivalent to, oops, to, it's also equivalent to 2 6. So this one piece is either 1/3 when it's in 3 pieces, it's either 4 twelfths when it's broken up into 12 equal parts, but it's also equivalent to 2 6 when it was broken up into 6 equal parts. Okay, let's continue. Okay. Savannah has 2/4 yards of ribbon, and Lynn has 3/8 yards of ribbon. How can you determine whether Savannah and Lynn have the same length of ribbon? Tell whether 2/4 and 3/8 are equivalent. We're going to skip some of this part. We're going to do what we did yesterday to show an equivalent fraction. Using the butterfly method, if you multiply the numerator in the first fraction and the denominator of the second fraction, which we're going to do now, and the answer is that 2 times 8 is 16. And then you multiply the denominator of the first fraction with the numerator of the second fraction. 4 times 3 is 12. If those two products are equal, then they're equivalent. If they're not equal, if they're not the same, then they're not equivalent. So I can say that 16 2/4 is not equivalent to 3/8. So please make sure that you put this example into your Go Math book. It will absolutely help you while you're solving the next problems. Okay, let's go to the next page. Okay. Right now, I'm going to use the model to write an equivalent fraction. So right now, I have my denominator is 5, and I have one box shaded. So 1/5 of this model is shaded. I want to make an equivalent fraction here. So if I multiply whatever I do to the denominator, I have to do to the numerator. So if I multiply both of these by the same number, I will get an equivalent fraction. So I am going to just pick any number. I'm going to multiply the denominator by 2. And I'm going to multiply the numerator by 2. So 1 times 2 is 2. And 5 times 2 is 10. So that means if I break this up into 10 equal parts, 2/10 will be equivalent to 1/5. Let's see. 1, 2, 3, 4, 5, 6. I'm going to just take this in half. Now I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 is my denominator. It's in 10 equal parts. 2 of it is shaded in. Is that the same amount that's shaded in here? Yes, it is. So they are equivalent. If I wanted to make another equivalent fraction, 1/5, I'm going to multiply the bottom by 3, the denominator by 3, the numerator by 3. Whatever I do to the denominator, I need to do to the numerator. And that's 3/15. Now, I can use the butterfly method to see if 1/5 is equivalent to 3/15. Let's try that. 1/5, is that equivalent to 3/15? Let's say 1 times 15 equals 15, and 5 times 3 is equal to 15. So these two fractions are equivalent or equal. Let's use the butterfly method to do these two fractions. 1/5, is that equivalent to 2/10? Let's see. 1 times 10 is 10, and 5 times 2 is 10. Make sure you multiply these two. So is 10 equal to 10? Yes. So that is also equivalent fraction. So 1/5 and 2/10 and 3/15 are all equivalent fractions. Okay, let's go to the next page. I think the rest you can do on your own. But right now, they're saying use the model to write an equivalent fraction. Always to write an equivalent fraction, just multiply the numerator and the denominator by the same number. It doesn't matter what number it is, as long as it's the same number. So I can multiply them both by 4. 4 times 2 is 8. 3 times 4 is 12. Now on your paper, please prove to me that these are equivalent using the butterfly method. Please continue to work on the next 2 pages, and I will come around and help you if you have any problems.